So we'll pick up here today using that same idea that we're going to take now we're going to take a sort of random region rather than just a semicircle. I mean, it's not random, but it's y equals square root of cosine x, some region that we may not normally deal with. We're going to take that region from 0 to pi over 2, and that's where it hits the x-axis, and revolve it around the x-axis. So we get this like sort of the, turned on its side like the bottom of an acorn or something like that. And what we want to think about then is the cross sections of this perpendicular to the x-axis are all circles, aren't they? If we cut this vertically straight down and open it up, the faces that we should get that we're looking at should be circles. And so the area of the cross section should be each of these circular cross sections throughout. What should the area of those be?
Pi r squared.
It should be pi r squared. And we need to multiply the area of that by the thickness of it. And how thick is that? Is it thick in the x or the y direction? Which one has that very infinitesimally thin thickness to it? X or y?
The x direction.
The x direction. So we're looking at integrating pi r squared dx. And anytime we revolve around the x-axis, just some basic region here that's all the way up against the x-axis, when we revolve it around, we're always going to get circular cross sections. And we're always going to use the formula pi r squared. And the cool thing for right now, this will change as we get to some more complicated stuff. The radius is always equal to y, because that's what we've got. Our function that's up here above the x-axis, that's our radius. And so r is equal to y, which is the square root of cosine x. And so r squared ought to just be, in this case, cosine x. And we'll have pi times the integral from 0 to pi over 2 of cosine x dx. Does that make sense, everyone? And that should give us the volume of this irregularly shaped solid that we otherwise wouldn't know how to deal with. And let's integrate it and solve it. So what's the integral of cosine?
Sine.
So we got pi times sine x from 0 to pi over 2. That ought to give us pi times what's the sine of pi over 2?
1.
1.
And then sine of 0 is 0. So we end up with pi units cubed. Everybody good with that?
Just wondering, but are we supposed to know what the graph of y square root cosine x looks like, or do you just kind of?
No, you don't need to know what it looks like. Yeah, I mean, I just threw it up there because it's helpful for us to look at it. But even if you don't know what it looks like, you should at least know that since it's a square root, it's definitely above the x-axis. And no matter what it looks like, it's going to be the same process. So you don't need to know that. Yeah.
Okay, thank you.
Yep. All right, let's take a look at this one. We've got the region between f of x equals 2 plus x cosine x and the x-axis from -2 to 2. So if I revolve that around the x-axis, we're going to get something that looks about like that. Looks like a vase on its side or something. Do y'all agree with that?
Yes.
Wonderful. What's the radius? Should just be that function. So we should be able to write pi times the integral from -2 to 2 of 2 plus x cosine x squared dx. Pi, radius, squared, dx, and then from -2 to 2. Does that make sense to everyone?
Yeah.
Cool. Now, we could distribute this out and get 4 plus 4x cosine x plus x squared cosine squared x. And then you try to integrate that and you'd realize that that's a Calc 2 integral and you wouldn't be able to integrate it. So at this exact moment, we are going to learn how to use our calculator to find the integral, find the definite integral of some function. So if you don't have your graphing calculator by you, go run and grab your graphing calculator because we're going to need it for this. And this is really important because if you can't learn how to do this, if you don't learn how to do this, you're going to have a lot of trouble on the calculator section of the AP test. So y'all got a graphing calculator by you? Everyone good and ready with that?
Yeah.
Okay. Here's what you need to do. You're going to go into the math window. This is if you have a TI 83 or 84. If you don't have a TI 83 or 84, you're going to have to look up how to do it because those are the only two that I know how to use. So you'll have to look it up in your manual or online. You're going to go in the math window. You're going to go down to option number 9. You can also just hit the 9 on the keypad and it'll bring it up. And one of two things will happen depending on how old your calculator is. If you have a fairly new calculator, it's just going to pull it up with an integral. You'll have a blank spot at the bottom and the top of the integral for you to put in the limits. You'll put in your function there, 2 plus x cosine x squared. And then you'll put the x at the end next to the d that they have a blank space next to. And you'll integrate and get some number. And you'll multiply that by pi. And if you're in that boat, tell me what you get real quick. That's probably most of you. Like 50 something, I think.
Oh, I got 25.1327.
Last period, somebody told me 50, and that's what some 50 something. That's what they all agreed with. Anybody get something in the 50s? Check your calculator. Make sure it's in radians, not degrees.
I got 52.4288.
52.4288, so 52.429.
Yeah.
Perfect. That sounds familiar with what they got. So whoever said they got 25 something or another, check to make sure you're in degrees, or make sure you're in radians, not degrees, and then try and retype it. Okay, now did anybody's, when you typed in math and 9, you might have a slightly older version of the TI 83 or 84, and it just opens up this window that says FNINT with a parenthesis. Is that anybody? Because yeah, okay.
Yeah.
Yeah.
I
Okay.
have a FNINT.
Okay, so if yours says FNINT, here's what you've got to do. Within that parenthesis for FNINT, you've got to type in the function. So you'll type in 2 plus x cosine x. Make sure you put it in its own parentheses to square it. You're going to type a comma. You're going to type an x. You're going to type another comma. You're going to type your lower limit, another comma, your upper limit, and then you're going to close your parentheses. And that should evaluate the integral in terms of x from -2 to 2. So for those of you that have an older TI 83 or 84, that's what you've got to do if you get that FNINT window, and you should still get this same value. So is everybody able to get that value?
Yes.
Anybody still struggling to get that? Those of you with the older calculators, you're good?
I got like
Yeah, a couple seconds.
67.008, something like that.
All right. Did you make sure that you squared it?
Yeah, let me just check again, see if I
Yeah, just try and
put the
type it again.
parentheses
Just make
right.
sure you get the parentheses and then the square. Make sure the squared gets applied to the whole thing in the parentheses there.
Yeah,
And make sure you don't have the pi. If you have the pi inside, that's fine, but make sure it's not inside the parentheses for the squared part, because that'll affect it too. So I don't want to move forward until I'm sure everybody is able to get that on their calculator. If you're having trouble, you can take a picture of what you typed in and send it to me in Remind, or I don't know, maybe you can put it in the chat, I don't know. and I can troubleshoot for you, but I want to take a second here and make sure we can all successfully get that value. Like I said, if you're not getting that, one thing to check is go into mode and make sure your mode is radians, not degrees, which, because there's a cosine in here, that's very important.
I think that was it.
Yeah.
It's set to radian or degrees.
Okay, yeah, change it to radians, and then hopefully you'll get the right thing now.
Yep, got it.
Perfect. All right, everybody is good. Those of you with the FNINT, good. Everybody with the integral sign on there is good. Everyone's good. Okay. All right, my 8-year-old son just started piano lessons like a week and a half or 2 weeks ago. So he's practicing his piano right now, in case you were wondering why there's piano in the background. Let's see. Let's do another one of these before we move on to the more complicated stuff. Let's take the Hot Cross Buns. It's a good one. That's the first song I learned to play years and years ago. Let's take the function. What was the parabola I had on there? Did I give you guys 3x minus x squared on the quiz? That was the parabola I gave you, I think.
Yes.
Okay, so let's take the region between that and the x-axis in the first quadrant. And let's revolve it around the x-axis and find the volume. So what does 3x minus x squared look like? Probably already graphed it, right? It should look like this. That's the parabola. So we're going to take this region right here, and we're going to revolve it around the x-axis so that we get a bunch of circles. Good or no?
Good.
All right, what should we do then? What is our integral? What should our integral be? We should have a pi, right? Where are we going to integrate from?
0 to 3.
0 to 3. And what should our integrand, what should be inside of our integral?
3x minus x squared dx.
3x minus x squared
Squared.
dx. Okay. So I know that this is one that we could do using, we could do by hand, which you should be able to do this by hand. I would expect you to be able to do this by hand, but just in the interest of practicing with your calculator, make sure that we can get the correct value of that integral. Let's integrate that on our calculators and get an approximation for it. This is the, like I said, one that I would expect you to be able to do by hand. And when we have the quiz for these, I will give you some that are by hand and some that are with a calculator, and I will expect you to be able to do it both ways. Can you get a value there?
I got 20. Oh yeah, go ahead.
447 units cubed.
25.447 units cubed. Were you all able to get that?
Yes.
Yeah.
All right, let's do one more. This one I'm gonna have you guys do completely on your own. Let's take the function y equals 1 plus ln x do 1 plus ln x, and we'll say the region between that and the vertical lines x equals 1 and x equals 4. And it's also going to be bounded on the bottom by the x-axis, the region, so this region. between y equals 1 plus ln x, the x-axis, x equals 1 and x equals 4. And we're going to revolve it around the x-axis. So you guys, I'm going to pause the recording here and give you guys a second to set this up on your own, and then approximate this one using your calculator, because this is an integral you won't be able to do without your calculator. So I want you guys to try and set it up on your own. Ready to go. So our setup should have been pi, an integral with limits from 1 to 4, 1 to 4. Our function itself, 1 plus ln x squared, that's our radius squared, dx, and it comes out to be 33.575. Anybody have any issues with that?